Good evening. It is Friday, and this is the third installation of our architectural hand drafting tutorial. It is later than I had hoped to put it out, and I do apologize for that. Last time, we reviewed how to measure a building in order to draft a scale floor plan. That episode is available on my second YouTube channel, the address for which is shown in the corner down here. If you haven't watched the first two episodes, I would recommend doing so as the lessons build on and follow from each other. This time we will start drafting that floor plan. As you can see, here is the rough sketch of the floor plan with exterior measurements. I was not able to dedicate the time to get the interior measurements yet. Since the measurements for the outside wall indicate that at least one of the corners is not square, that is, at a 90-degree angle, we need to either find a corner that is square or find the angle of one corner if none of them are square. This will give us the best and most accurate reference lines from which to draw the rest of our floor plan. It is possible to measure an outside angle if you have a framing square or this kind of protractor, but it is likely easier to measure the angle of the corner from the inside. Measuring the inside of a corner only requires a tape measure. The angle of the inside wall in most cases is going to match the angle of the outside of the wall. Even if you can't measure the foundation wall itself, because, for example, you are in a finished basement and the inside of the foundation wall is covered in furring strips and wallboard, which are furring strips are the wood studs in this picture and the little X'd out boxes in this example plan. Those are, or should be, of even thickness, and therefore the face of the finished wall will still be parallel to the face of the foundation wall. To measure whether a corner is square, we are going to make use of the 3, 4, 5 triangle, which you may remember as part of one of the proofs of the Pythagorean theorem. We are not using this theorem, just the triangle. From the inside corner of the wall, you will measure 3 units on one wall, and 4 units on the other wall. If your corner is square, the distance between the endpoints of your wall measurements will be 5 units. I say units rather than feet, because you can use any unit of measure as long as it is consistent. You could measure 3, 4, and 5 inches if you were so inclined. I would not recommend that small a unit, because the larger the distance that you measure, the more accurate your angle will be, and the less it will be affected by, say, an uneven coat of drywall mud in the corner. So, we measure 3 units this way, and 4 units this way. And this distance, the hypotenuse, is 5 units. Therefore, this corner is square. On this corner, measure 3. Let's make that a little more accurate. 3. 4. 'And a little more than, no, do we have it? Yes, and a little more than 5, which means this corner is not square. If space permits, you could measure a larger or smaller distance with the same triangle by multiplying each side by the same factor. For example, you could measure a 6, 8, 10 triangle, each side of the triangle being multiplied by 2, or a 9, 12, 15 triangle, each side of the triangle being multiplied by 3, or a 1.5, 2, 2.5 triangle, each side being multiplied by 1/2. In any case, if the hypotenuse is not the appropriate multiple of 5 units, your corner is not square. You can either try to find a square corner on your plan or on your building, or you can measure the angle of the non-square corner. To measure the angle, you will need a protractor. Here are a couple examples of protractors that could be used for this purpose. If you do not have an official tool, you can fake it by laying 2 straight pieces of wood on top of each other, running a screw through the end, and opening them to put the sides against the walls. Try to get the screws centered in the width of the boards and a distance equal to the center measurement from the end, unlike what I've done here. This will still serve as an example. So you line it to the walls, and then you can use a geometry protractor to see where it comes out. This one appears to be 92 degrees or something. If your corner is square, you shouldn't need an additional reference to do the plan. If your corner is not square, you will need to measure a second corner as well. But once we have our corner angle, we can use it and the measurement of the building faces to draw the outline of the building. We have the total measurement for each face of the building here. This gives us the largest extents of the building, which will help us choose the right scale for the size of paper we have. The south face is 534 inches. The south face. 534 inches, which is 44.5 feet, or 44 feet and 6 inches. The east face is 334 inches, which is 27.83 feet, or 27 feet and 10 inches. The north face is 517.25 inches, which is 43.10 feet, or 43 feet and 1 1/4 inches. The west face is 338.5 inches, which is 28.21 feet, or 28 feet and 2 1/2 inches. As a side note, the best way that I have found to calculate feet from inches on a standard calculator is this. Take the number of inches and divide it by 12. This will give you the number of feet plus an entirely unhelpful decimal remainder. Ignore the decimal remainder for the moment. Take the resulting number of feet and multiply it by 12. That will give you the number of inches in that number of feet. Subtract this number of inches from your original measurement, and that will give you the remainder in inches rather than in decimal. So the remainder is 1¼ inches, leaving us with 43 feet, 1¼ inches. Ignore the sign there, you'll figure that out. Okay. If you have a calculator programmed to give you an output in feet and inches, which do exist, you can skip the tedious calculations, or you can take your measurements in feet and inches instead of just inches, which means you get to do math in your head outside in the field. So, our paper is 12 inches tall. We can make it as wide as needed. Since the east and west faces of the building are the narrow sides, we will match them with the narrow sides of the paper. We will leave some margin, a bit less than 3/4 of an inch, between the top and bottom edges and the outside of the building plan. But if we look at our various scales, let's see, we're looking at around 28 feet. If we look at our various scales, we can see that the 3/8 inch scale, which goes out to 28 feet in less than 12 inches, is going to be the largest scale we can fit on this size of drafting paper. With 1/2 inch scale, we can only fit about 20 feet on the paper, and with 1/4 inch scale, we could fit the narrow end of the building on the paper approximately twice. If we wanted to use 1/2 inch scale, we would have to get 18 inch wide paper, which does exist and is quite nice. I just don't have any on hand. So 3/8 it is. The first thing to do is draw a reference line from which we can measure. This should be one of the lines that intersects the square corner or your corners with the known angles. So we're going to use the south face of the building for this. Since this corner is the square one, we can just use, we have to find the corner first. This face is 44 feet and 6 inches long. Half of that is 22 feet and 3 inches. So, if we just find something, let's put that mark at the 3 inch mark, then go out here to 22. That'll give us our 22 feet 3 inches. Then we can put this 22 there at the mark, and then put a mark on our line again at 3 inches. So 22 feet 3 inches, 22 feet 3 inches, for a total of 44 and 6 inches. Since this is our square corner, we will just place our triangle flush against our straight edge. And use that to draw our line all the way up. If this had not been a square corner, what we would have done is take our protractor, align it with the first reference line and the corner mark, mark the degree of our corner, mark the angle of our corner, and then just use the triangle as a straight edge, not resting against anything in particular. Use that to connect those 2 points and extend the line out, and that would give us our not square line for the wall. So the next thing to do is we need to find the length of this corner. As the east elevation is 27 feet and 10 inches. So we will place the 27 foot mark on our corner here. Line the scale up with the line, and then put our mark out here at 10 inches. That gives us the location for that corner. Now to do these other corners, we don't know what the angles are, so what we're going to do is use a compass. I showed you this compass in the first lesson, which is useful, but it does not have the same, it can't scribe the same distance as this one can. This compass is set to the scale distance, which is the north wall's 43 feet, 1 1/4 inches. To do that, we set the point on this corner and we scribe an arc. This compass I have today is called a bar compass, I believe. We'll have to adjust it to scribe the length of the other wall, and where the two arcs intersect will be our corner. So we are looking at, for the west wall, 28 feet and 2 1/2 inches. We can't actually get to 2 1/2 inches precisely because this scale is too small to measure that precisely, but we can get it to, somewhere between 2 and 3 inches. Put the point on this corner. And there's our corner. Now we can use a straight edge to connect these 2 points. And those are the extents of our building. So when you draw a line, at least for this initial layer, make sure that you are drawing the line well past the length of the wall itself. This will keep your corners cleaner and more precise when you trace them for the final sheet. Once we have the outlines of the greatest extents, we can mark the corners for other features of the building, like the porch and the back addition and the south bump out. Since we can't be sure that any of these are square, we're going to use the compass for that as well. I'm going to break it down into a shorter format. So if we start up here on the east elevation, we've got the porch, which is approximately 8 1/2 feet in and 4 feet 1 inch deep. So what we're going to do is measure 8 feet 5.5 inches. Or as close to it as we can. So 2, 4, 6, 8. And with our inch marks there, that'll give us the correct depth. And four feet 1 inches in. Do the same for the other one. That should be our corner. Now for this other side, we have to come in from out here. So we're going to be measuring in 3 feet 8.5 inches plus 7 feet 7.5 inches, which is 10 feet. 7 and 8.5 is 15.5. So 11 feet 3.5 inches. And you'll be flipping your scale around to however it fits on there. What did I say? 3.5? 3.5 and 11. 2, 4, 6, 8, 10. You have to be careful not to use the wrong 10. And then this section is out 4.4 feet, or 4 feet 4 inches. Then we'll take it out to the 11, 3.5. That's just about perfect. You don't actually necessarily have to use the compass for everything if you have a building that was built square. This particular building is more than 100 years old, not built square, so we're doing our best. Okay, so now we have this section here, which is 4.4, or 4 feet 4 inches. I don't know why I keep saying that's 0.4. 4 feet 4 inches plus 14 feet 10 inches is 19 feet 2 inches. And this distance here is 3 feet 8.5 inches. Let's see, we're looking for 3 feet 8.5 again. From this point. Oops. Now we're looking for a nice little 6'11" square out of this corner. This section is 13 feet 8 inches long. And 3 feet 9 inches deep. Hypothetically, we could use this distance from that point to catch our intersection, and we might do that. Okay. So that's the frame of our house. I think hypothetically we could continue for tonight and mark the locations of the windows and doors. We don't have interior measurements yet, so we can't finish the floor plan, but we do have the outline of the building at least. I think we will work more on the floor plan next time. I will get the interior measurements. We will add details to this. This video will be available on Twitch for the next 7 days, and will shortly be available on my second YouTube channel at Featherblade000, shown in the lower corner. If you have any questions about this lesson or the previous lesson, please feel free to leave a comment on the video on YouTube, and I will answer it as best I can either there or in the next drafting video. I'm afraid that my schedule is a bit messed up right now, so the next lesson may not be for a little longer than 2 weeks, but I hope you will join me for it once I get it together. It might actually just turn into finishing the rest of this draft. So, thank you for watching. I appreciate your company. I hope you enjoyed this, and I hope you have a lovely weekend. Good night.